one of nature's most dramatic wonders, a volcano spewing red-hot lava, churning with the energy far beneath us that creates much of the material we call rocks, that are the basis of our natural environment. Developed in different ways, rocks and the minerals that form them are clues to our planet's past and are part of a constant cycle of change on the Earth's surface. Made up of natural substances called minerals, rocks are the result of forces that, in the past, formed the Earth's crust and continue to do so today, as part of a never-ending rock cycle in our planet's surface environment. Of the many different types of rocks, there are three main groups or families of rocks: igneous, sedimentary, and metamorphic rocks. Rocks in these families are formed in various ways, and then once formed, they can be changed by such conditions as heat, pressure, and weather or chemical reactions. These processes may take hundreds, thousands, or many millions of years, as part of a cyclical change on Earth that we call the rock cycle. First, let's take a look at igneous rocks. Most of the rocks beneath the Earth's surface are igneous rocks. This type of rock is formed by the cooling of molten material called magma deep within the Earth. In fact, igneous comes from the Latin word ignis, meaning fire. The Earth is made of layers: the surface crust, the mantle beneath it, then the outer core, and finally, the inner core. Beneath its surface crust, the Earth's mantle is nearly 3,000 kilometers thick. Both mantle and outer core are molten hot, containing the fiery liquid magma. Correlating data from sophisticated recording and measuring devices, geologists say the planet's inner core, made of solid iron, is actually spinning freely, revolving, some geologists claim, even faster than the Earth's surface. According to geologists, the magma cools as it makes its way under pressure towards the Earth's surface. When the magma comes to the surface through a volcanic opening like this in Hawaii, it becomes lava. Intrusive igneous rocks are hardening magma thrusting to the Earth's surface. These rocks, like the ones examined here by geologists, can take millions of years to cool. Look closely. What characteristics do you observe in these intrusive igneous rocks? As you can see, these rocks have coarse textures and large mineral grains. Generally, the slower the cooling process, the rougher the rocks will appear. If you're looking for intrusive igneous rocks where you live, the rock you may very well find in many areas of the United States is this one: granite. Granite is the most common igneous rock formed beneath the Earth's surface. Found in the United States, this coarse-grained rock is especially common in the Rocky Mountains in the west, the Adirondack Mountains of New York State, the White Mountains of New Hampshire, and the Black Hills of South Dakota. Chances are where you live, you'll spot granite in monuments and buildings because it's strong and durable. Architects and builders prefer a fine-grained granite because it takes a high polish and presents an impressive surface. Extrusive igneous rocks, on the other hand, are formed on the surface of the Earth. Since extrusive means forced out, these rocks are mainly forms of lava. As magma is forced out through a volcanic opening, it becomes lava. A rapid cooling process takes place, resulting in different forms of extrusive igneous rocks. Extrusive igneous rocks generally have a finer texture than intrusive igneous rocks. Geologists tell us that the faster the cooling process above ground, the smaller the mineral crystals will be in these rocks. But nonetheless, there's a wide variety among rocks derived from lava. For example, notice this object floating on water. What do you think it is? This is a piece of pumice, the only known rock to actually float on water. Pumice is what scientists describe as rock froth. Containing many air cavities, pumice is formed when dissolved gas escapes from a lava flow. This visually striking piece of obsidian, on the other hand, is a kind of volcanic glass. Usually black or green, obsidian is produced when lava cools so rapidly that mineral crystals have no time to form, resulting in a rock unusually smooth with sharp edges. Let's suppose a friend finds this rock, and several others like it. And later, you find this rock. Now ask yourself, is the rock your friend found smooth or coarse-grained? Does it have large crystals? It's fairly obvious this rock is coarse-grained and has large crystals. How about the rock that you collected? Is it fine-grained, or are the crystals large? The rock is very dark, so dark and fine-grained, in fact, that you can't see any crystals at all. Now ask yourself, which of these two samples is extrusive igneous rock and which is intrusive igneous rock? Your friend's rock, the sample on the left, is a piece of granite, and with its large crystals is an intrusive igneous rock. While the sample you found is basalt, a fine-textured extrusive igneous rock. How do you think rocks are formed on the Earth's surface? According to geologists, new rocks are formed above ground in a variety of ways, as part of the continuous recycling of rock materials known as the rock cycle. But most of these surface rocks, in fact, about 75% of them, are classified as sedimentary rocks. On the Earth's surface, there is much loose material called sediment. Existing everywhere you go, this sediment may take the form of pebbles, clay, the soil in fields, or the sand on beaches. Through geological processes over periods of sometimes millions of years, these sediments become sedimentary rocks. During these formative stages, the loose sediment is gradually deposited in layers. The layers, called beds by geologists, are a characteristic of sedimentary rocks. In sedimentary rocks, you'll find the oldest beds on the bottom and the layers formed recently on top. Notice the layers of sediment in these views of sedimentary rock in the Grand Canyon. How does such layering occur? Here you can see how sedimentary deposits naturally separate into layers. First, into a jar filled with water, we'll place small portions of soil, gravel, sand, and some black carbon from plant remains. Now, shake the jar and its contents vigorously, and leave it to settle naturally. Then, 2 days later, you can see how the sediment, the various kinds of particles, has settled into layers or beds. This 48-hour demonstration is similar to the geological process by which sedimentary rocks are formed over periods of millions of years. Geologists divide sedimentary rocks into 3 main types: clastic, chemical, and organic. First, let's look at clastic sedimentary rocks. Clastic sedimentary rocks are formed when particles and fragments of rocks, through erosion and exposure to weather conditions over long periods of time, are compressed and then compacted until they become solid rock. The formation of sedimentary rock is similar to the process of making modern cement that we see here. In the case of sediment, as water moves through soil and rock fragments, dissolving minerals like quartz and calcite become natural cements that over many years compress particles into rock. Most of the Grand Canyon, for example, is made of sandstone rocks that are the result of sand particles cemented by nature over millions of years into the layers or beds of sedimentary rock. And when you're collecting pebbles at the water's edge, perhaps at an ocean beach or along the bank of a stream, you can see that the pebbles are fragments of rock smoothed by the flow of water. When these pebbles are cemented by nature into rock form, geologists call them conglomerates or pudding stones. Another type of sedimentary rock is stone formed through the action of chemicals. In this case, layers of chemical sedimentary rocks develop when certain minerals dissolve in water. For example, limestone, like we see here, is often formed when calcium carbonate dissolves in water. The third kind of sedimentary rock is organic sedimentary stone, containing the remains of fossils of plants and animals that lived millions of years ago. In some regions, plant material from hundreds of millions of years ago was compressed into rock, creating coal, which is known today as one of our fossil fuels. Think for a moment. If a scientist finds a fossil, the ancient remains of an animal in a layer of sedimentary rock, how can we tell the general age of that fossil? Remember, sedimentary rocks are usually formed in layers or beds, with the layers on the bottom older than the layers on top. Thus, if geologists like these can determine the age of sediments containing fossils, they can figure out which organisms came first and which lived later. Using this method, scientists have determined when dinosaurs like these lived and when they disappeared from the surface of the Earth. How do you think scientists can use sedimentary fossil remains to decide when an organism like the dinosaur became extinct? Scientists say fossil remains of dinosaurs seem to disappear in layers of rocks younger than 65 million years. In other words, at that point in our planet's history, dinosaurs were no longer present on the Earth. The exact reason for their disappearance remains one of the great mysteries of science. The mudstone you see here is a sedimentary rock which often contains fossils. Called shale, this type of layered rock frequently has the remains of former plant and animal life buried in mud millions of years ago. And for the fossils of ancient sea animals, a frequent source is the sedimentary rock we discussed earlier, which is limestone. The three kinds of sedimentary rock, then, clastic, chemical, and organic, are in a sense like layers of history, or you might say, pages from past life on Earth. Since fossils found in sedimentary rock are as old as the rock's layers, scientists are provided with glimpses of our planet's history, indicating where oceans and deserts once were, whether the climate was warmer or colder, and what plants and animals once existed. So far, we've discussed igneous and sedimentary rocks. The third main group of rocks on Earth are metamorphic rocks, rocks that are formed by extreme heat and pressure. To understand the process resulting in metamorphic rocks, let's take a look at this sculptor making a clay pot. First, he molds the soft clay into the form desired. Then, he places his work into a kiln or oven. What do you think will happen to the clay pot after several hours baking in the kiln? Here, several hours later, we see the sculptor's work. Baked by the kiln's hot temperatures, the finished clay product has become hard and brittle. The soft clay has become what we know as ceramic. Deep within the Earth, a similar process occurs with rocks. Here, far beneath the planet's surface, rocks, like the artist's clay, are transformed by intense heat and pressure. These changes may affect already existing igneous, sedimentary, or even metamorphic rocks. During such a change, the extreme heat and pressure beneath the Earth's crust cause the mineral crystals in the rock to change shape. Often, the minerals are flattened. In some cases, they exchange atoms with adjacent minerals, becoming larger and different in composition. Limestone is a sedimentary rock, which often becomes marble, like this. And shale, a fairly common sedimentary rock, is often turned into the hard, durable metamorphic rock, slate. In the constant process of rock formation, 3 basic factors determine what type of metamorphic rock a rock will become. These factors are how deep beneath the Earth's surface the rock is buried, how much heat the rock is exposed to, and how long the rock is exposed to these conditions. Often formed under extreme conditions, many metamorphic rocks can withstand severe weather demands and are excellent construction materials. A slate roof like this will last many more years than a conventional asphalt roof. Metamorphic rock, then, is a recycled form of rock, developing from igneous, sedimentary, or already existing metamorphic rocks. These rocks are masses of minerals that, through extreme heat and pressure, are recomposed, becoming new rocks with different characteristics to serve new purposes in our natural environment. Geologists call this continuing cycle of change the rock cycle. As we've discussed, the 3 different types of rock are interrelated. To start the rock cycle, we have igneous rocks, created beneath the Earth's crust from red-hot magma, and then above the surface from volcanic lava, like this lava flow in Hawaii. Exposed to severe weather conditions over a period of many, many years, such igneous rocks are eroded, fragmented, and broken down into sediments. Sediments that may accumulate and gradually, again over millions of years, become sedimentary rock. Then, again, during millions of years, such sedimentary rock can sink, recede into the earth, until it's buried beneath the surface. There, increasingly far beneath the Earth's surface, sedimentary rock, like the rock in this cave, can be exposed to tremendous pressure and heat, and gradually transformed into metamorphic rock, some of which may gradually and eventually appear on the Earth's surface. Other metamorphic rock may be melted by the intense heat in the Earth's interior and become magma before cooling and crystallizing into igneous rock, which once again will probably work its way under pressure to the Earth's surface, thus completing the rock cycle. Somewhere on Earth, new rocks are always being formed, while in other places rocks are being destroyed, remelted, and reformed. Virtually everywhere on Earth, rock materials are constantly recycled in a never-ending process taking millions of years, in what geologists call the rock cycle. This is how scientists say the Earth appeared millions of years ago. And this, of course, is how it appears today. The rock cycle, a slow, continuous process, takes millions of years. So chances are the land around you will look the same next year, 100 years from now, and probably even 1,000 years from today. But how do you think your neighborhood might look 10 million years from now?